Okay, so we are going to start, we're still under the same umbrella of solving trigonometric equations. So remember, we are solving, which basically solving always means getting the variable by itself. So we are still under the umbrella where we try to get theta by itself. We're solving for that theta. And you saw that in day 1 and day 2 where you tried to get, it was a linear equation, quadratic equation, and sometimes you have to use trig ID. And doing any of these, your goal is to get that theta by itself. But today we're looking at something a little different, multiple angle type. So it may be a little more work than what you did on day 1 and day 2, but yeah, but like I, just keep at it and learn it well, and you'll get there. So for now, what I'll do is I'll just write down the notes here, so that at any time you want to go back and look at the notes, reread the notes, and so that for it to make some sense, you can do that. Okay. So the first, I'm not even going to read it, I'm just going to fill in the blanks because we have not yet done any problems, so I can't explain it to you. Once we start the problems, you'll be able to relate to what I'm writing down. If the coefficient of theta is between 0 and 1, you're going to fill up less. If the coefficient of theta is greater than 1, then there will be more solutions. For sine, cosine, secant, cosecant, and I'm going to also add, but because you'll see there's a separate line for tangent and cotangent, we will use the same generalization. So for now, I'll say for tangent and cotangent, use the same as above. And I'm going to write down what that above is. We're not going to make it different. Actually, you'll see in the key that's posted, the notes key, you'll find that tangent and cotangent, we do it slightly differently. But even if you do this, keep the same rule, it's the same. So for now, just write this down, same as above for tangent and cotangent. And what are you going to do for sine, cosecant? Use the generalization, add 2 pi k, where k is an integer. That means starting at 0, 1, 2, dot, dot, dot. It'll keep going depending on how many values of k you need to use. And you'll see that. And you'll need a generalization for all angles between 0 and 2 pi. That means that's where your solutions are going to be. That's where your solution. And that'll actually be given in the question. So what are we doing here? What is so different about this particular multiple angle solution? So what we're going to do, I'm going to start explaining what we're doing here while solving a problem, instead of trying to be kind of conceptual and explain it before. So there is a tan 2 theta problem here, and there is a sine 3 theta problem here. So that's why it's called multiple angle. So if you see in my previous problems, unless it was a double angle, it was always tan theta, sine theta, cosine theta. But here, what are we noticing? 2 theta, the theta is a multiple angle. That's why it's called multiple. It's 2 theta, sine has a 3 theta, cotangent again has a 3 theta, cosine has 4 theta. So we're talking about multiple angles. So the minute you see this, you will use a different procedures. Okay, so let's talk about this. So I'm going to start with sine rather than with tangent, and then we'll jump to 1. So let's start with number 2. So keep in mind, your goal is still to get theta by itself. So what did we do when we tried to get theta by itself? We tried to isolate the term that contains theta. In this case, which one is that? In this case, it is the sine 3 theta, correct? So what will you do to isolate this? We can all do this. So you subtract. So 4 sine 3 theta equals square root of 3 minus 3 square root of 3. What is this? When you subtract, that's what you're doing, right, to both the sides. Can I subtract these two? Can I subtract square root of 3 minus 3 square root of 3? Yes, you can. You know why? Because they have the same. Remember, you can always subtract radicals as long as it's the same radical. So it's like saying 1 minus negative 3 of square root of 3. So this one is actually negative 2 square root of 3. So going back to basic math. Okay. And then I keep going. Sine 3 theta equals, divide by 4 on both sides. And so when you divide this by 4, okay, let's just write it down. I'm trying to skip steps, but which is actually sine 3 theta equals to, I can simplify this alone, right? So that negative stays, and 2 over 4 is 1 over 2, square root of 3 over 2. So what do you notice here? You notice that sine 3 theta equal negative. So now negative square root of 3 is on my unit circle. So I can use my unit circle to find out when theta is going to be, at what angle is sine square root of 3 over 2. So if you look at our unit circle, when is sine square root of 3 over 2? It is at pi by 3. So you find the reference angle of pi by 3 wherever sine is negative. Sine is negative here and here. So my solutions will be in this one, 1 pi by 3, 2 pi by 3, 4 pi by 3, and 5 pi by 3. Those will be the two statements you write. Okay. So this is where I'm not writing it down straight away because of a reason. I'm going to tell you why. It's not theta that's, so now in my previous day 1, when I did day 1, day 2, I just said this was theta. So I just said theta equals to 4 pi by 3 and 5 pi by 3. But it's not theta, it is 3 theta. So I'm going to say 3 theta equals to 4 pi by 3. And I'm going to leave a little space and I'm going to tell you why. Sorry. 3 theta equals 5 pi by 3. Okay. And remember, look at what we had said in the notes. I'm going to jump back to the notes. For sine, cosine, secant, cosecant, and tangent and cotangent, add 2 pi k to both the sides. So that's what I'm going to do. And I'm going to explain to you right now why we do that. Plus 2 pi k. When this you do whenever it is a multiple angle identity. So why do we do that? So I'm going to talk about this a little bit. This is a little conceptual. So I'm going to go back to our equation. What does this 3 theta stand for? So 3 theta, 3 is nothing but the coefficient of theta, which is actually same as x. Remember, I always said 3 and they are interchangeable because that's the input. And in case of trig, the input is an angle, so we use theta instead of x, but it's the same thing. So the coefficient of x, so if you go back to your graphing where we learned how a sine equation is written, a sine equation is written as y equals to a sine b x minus c. You guys remember this? Hopefully this is all coming back. And what do you know about the coefficient of x? The coefficient of x is bx. C is the horizontal shift. B is the vertical shift. That means the wave is going forward or backward. Wave is going up or down. Amplitude. And the B is the, do you guys remember? This is the one that defines the period. And what do we know about the period? What do we mean by the period of a wave? So period is basically, the formula was 2 pi by b, but that's more importantly, what does the period tell you? The period tells you that whether the wave is compressed or elongated. So remember, my wave if b is 1, so my wavelength is going to be 2 pi, so 0 to 2 pi. Right? I'm sorry, I shouldn't put a dot here because it goes on. So this is 0 and this is 2 pi. But if my b is 3, like in this case, right, that's my b is 3 theta, 3x. What does this mean? 2 pi, my period becomes 2 pi by 3. What does this mean? That means my one wave is going to go from 0 to 2 pi by 3. So how many waves fit in from 0 to 2 pi? 3 waves. So it basically means my wave is actually compressed. My wave is actually compressed. And B is a very important concept. I think I've talked about this, that this is the one that actually you tweak the B and it actually, you compress the wave or elongate the wave, and that actually changes the tone when you're looking at a piano and stuff like that. It changes the tone of the piano tone, basically. The difference between C key, I'm not aware of the keys and the exact name, but the C key and the G key or some of the different sounds they make, the people who build the piano actually tweak the formula for this. So it's an important concept. So basically for you, what you need to know is when my coefficient of x changes to a number greater than 1, if the coefficient of 0 is greater than 1, like in this case it's 3, and not, there will be more solutions. Why are there more solutions? See, how do you find solutions where it hits the x-axis, right? How many times is it hitting the x-axis here? 1, 2. And if you don't take 2 pi, if it's less than 2 pi, it's just 1, 2. Here, how many solutions? 1, 2, 3, 4, 5, 6, 7. If you don't take this. So 6 solutions, actually, if I don't take 2 pi. Because the reason I'm saying you don't take 2 pi is less than 2 pi. It's not including the 2 pi. So instead of 2 solutions, I'm getting 6 solutions. So you have to find those more. So how do you find those extra solutions? And that's what the mathematicians found. I find my extra solutions by doing that plus 2 pi k. And you'll see as I go to solve, continue with this, substituting for k to be 0, 1, 2, like what I say in my notes, you'll find your other solutions. Okay. So having said that I add the 2 pi k, what you need to understand is that I'm solving for theta. So this is one important step. that you write 3 theta, and then when you write the 3 theta, you add the 2 pi k. That's an important step. Add, so keep in mind, we're looking at step 3. And then, but keep in mind we are solving for theta, not for 3 theta. So how do you go from 3 theta to theta? You divide all sides by 3. So divide by 3 because that's my goal. What is my goal? My goal is to get theta by itself. I have 3 theta. You don't want 3 theta. Divide by 3. Dividing that by 3, you can't do something just to the left hand side. You have to do it to both the sides of the equation. Dividing that by 3 is the same as multiplying by 1. They're the same thing, right? So I'm just going to, instead of dividing this whole thing by 3, I'm just saying same thing. Divide by 3, multiply by, here, I'm going to write it on this side, 1/3. Hopefully this is clear. I know there's a little bit of scribble, but basically your goal is to get theta by itself. So I do this, divide by 3, but dividing by 3 also is the same as multiplying by 1/3 on the other side. Okay, let's see where we go from this. So I've got my goal here. This will give me theta. What happens here? You have to multiply to both the sides. I'm sorry, you have to distribute to, you have to distribute to both the terms. So 4 pi over 3 multiplied by 1/3, you multiply top to top, bottom to bottom. So this becomes 4 pi by 9 plus 2 pi k. That doesn't go anywhere. Okay, let's keep going. You have 2 solutions. You have to work this for both the solutions. This cancels. Theta equals, again, you multiply this to both the terms. 5 pi times 1 is 5 pi. I'm so sorry, I forgot to do this. I'm really sorry. 2 pi k multiplied by 1/3. I'm making them by 3. Right? I completely forgot it. That is totally my fault. I realized it at this point. And then 5 pi times 1 is 5 pi. 3 times 3 is 9. And remember, you have to multiply 1/3 to the second term, 2 plus 2 pi k over 3. Okay, so remember you have to multiply to both the terms when you're distributing it, and I made a mistake here. Yeah, so but I corrected it. Okay, now what you want to do is you want to start substituting for k. When you start substituting for k to be 0, 1, 2, and so on and so forth, you have to add these two, right? When you substitute for k equals to 0 or k equals to 1, you have to add the two fractions. What is the best way to add a fraction? The best way to add a fraction is they have the same denominators. So even before I start substituting for k, make them have the same denominator, because you're going to substitute for k multiple times. So instead of trying to make them the same denominator multiple times, let's do it at one stretch. So theta equals 4. You want them to both have 9 as the denominator, because this is 9, this is 3. I can multiply top and bottom of this with 3, top and bottom of this with 3. Because this is also 9 and 3. So what happens here? So this is what I did. Why did I do this? So that they'll have the same denominator. So this becomes 4 pi over 9 plus 2 pi, top and bottom, right? So you have to multiply both. So bottom is 9, that part is easy. So 2 times 3 is 6, so this becomes 6 pi k. And theta equals 5 pi 9 stays the same, plus 3 times 3 is 9, that was our goal, and my top bottom is the same, 6 pi k, right? 2 times 3 is 6, 6 pi k. Alright, so now I have theta. I can solve for theta because it's easy for me to solve. It's not that I couldn't do it, but it's easier now because I have the same denominator. And now you start substituting for k. So the thing is, how long do I keep substituting for k? I take k equals, you have to start with k equals to 0. You have to start with k equals to 0. Okay, so let's just do that, and then I'll tell you where to stop. So if k equals to 0, anything times 0 will be 0. So this whole term is gone. So my first set of solution is going to be theta equals to 4, when k equals to 0, 4 pi by 9, and theta is equal to k equals to 0. I'm still at k equals to 0. So this whole term is gone. So 5 pi by 9. So this is my first set of solutions. Then you're going to go to k equals to 1. Now how do I know how long do I keep doing? So basically this is what you need to understand is you need to stop for theta when it is less than 2 pi. Less than 2 pi means what? Theta has to be less than 2 pi. But we are calculating with 9 as the denominator. We're calculating with 9 as the denominator. Not less than, equal to, just less than. Less than 2 pi. And with the 9 as the denominator, what is it? What will the top be for it to be 2 pi? 9, it will be 18 pi. So this is what is important. That you have to basically stop when you do your calculation, that you stop when it is 18 pi by 9. And you see that 5 pi by 9 is way less than 18 pi by 9. So I have to keep going. I'm going to keep going. So k equals to 1. Let's see what's happening with that. 6 pi times 1 is just 6 pi. So literally my denominator stays the same because that's the whole idea. So 4 pi plus 6 pi is 10 pi. Did everybody get this? K equals to 1. 6 pi times 1 is 1. So 6 pi plus 4 pi is 10 pi. That's my next solution. And mine's K equals, I'm still at K equals to 1. K equals to 1. 6 pi plus 5 pi is 11 pi. So this is my next set of solution. Should I go to K equals to 2? Yes, because 11 pi by 9 is still less than 18 pi, very less than. So let's keep going. And you'll actually know where to stop. K equals to 2. K equals to 2. Theta equals to, let's look at this. So this is, okay, so let's highlight this. This is the equation that I'm substituting for K. These two equations. Okay, so now I'm substituting for K equals to 2. So what is 6 times 2? 12. So 12 pi plus 4 pi is 16 pi. Everybody got that? 6 pi times 2 is 12 pi. 12 pi plus 5. 12 plus 5 is 17 pi. So I got 2 more solutions. Now is a good time to stop, because when I go to K equals to 3, it will definitely cross 18 pi by 9 because I'm already at 17 pi. Let's look at this. 6 pi times 3 is 18 pi. 18 pi plus 4 will definitely cross it. So you stop right here. These are my 6 solutions. And this is what I was talking about, that you're going to have many more solutions, right? Which is what I told you, that my wave is compressed. So you're talking about many more solutions. And those are many more solutions. And so having just 2 solutions, which is 4 pi and 4 pi by 3 and 5 pi by 3, I have 4 pi by 9, 5 pi by 9. These are all the spots that my wave will hit the x-axis. So this is the process to do when you, basically when you have, when theta is, the coefficient of theta is more than 1, Okay, now what we're going to do is I'm going to jump back to the notes and we're going to do for the tan theta. Same process, and once we do this a few times, the process will get clearer. Okay, so let's look at this. I'm just going to do the whole thing in a separate piece of paper because we are short of space generally. Tan 2 theta equals to -1. Okay, let's go through all the step process. Remember what we said? We said that, I'm just trying to put this notes away. Yeah, here. Our first step number 1 is to isolate the term that contains theta, which is in this case it's tan 2 theta. Luckily for me, tan 2 theta is already isolated. I don't have to do anything. Then you're looking at the unit circle to see when is tan theta negative. Forget about the 2 part. When is tan -1? We know tan is 1 as pi by 4. But where is it negative? Tan is negative here. All students take it. I know it's positive here. So my two angles where 2 theta will be, if this is, in this case, pi by 4, it's 3 pi by 4 plus 2 pi k. We know we have to do that now. And 2 theta equals to 3 pi by 4 and 7 pi by 4. This is, the reference angle here is 7 pi by 4. So 7 pi by 4 plus 2 pi k. Okay, alright, let's keep going. And then remember, my goal is to get theta by itself. Theta is not by itself, so I divide both sides. Either divide by 2 or is the same as multiplying by half. Dividing by 2 is the same as multiplying by half. Okay, so 2 theta divided by 2, this cancels, so I have theta, I'm getting closer to my goal. And then, because I multiplied by half, you will distribute the half to both the terms. Let's not forget to do it to both the terms. Last time I forgot. 3 pi times 1 is 3 pi. And 4 times 2 is 8. I have to multiply, I have to 2 pi k and over 2. Should I simplify it? You could, but just wait, we can leave it for now. We can do all the simplifying in the end. And the same thing, theta equals, distribute 7 pi over 8 plus. So just distribute it to both the terms. Okay. Now my goal is to start substituting for k, but before I do that, I want them to have the same denominator because I have to add them. I have to add fractions, and you want the same denominator. So I'll do that right in the beginning rather than do it every time I substitute for k. So how do I make them the same denominator? Multiply this fraction with 4. Does that make sense? Because 4 times 2 is 8. 4 times 2 is 8. I'm just highlighting the new things that I'm adding. So theta equals to 3 pi over 8 plus, bottom is 8. What's my top? 4 times 2 is 8, right? And pi k stays as it is. And theta equals 7 pi by 8 plus, bottom stays as 8. That's the easy one. And this is 2 times 4 is 8, 8 pi. Okay, let's keep going. Now that I have the same denominator, I'm ready to start substituting for k. So k equals to 0. Oh, before we do that, when do I stop? Theta needs to be less than 2 pi, but 8 is my denominator, so 16 pi by 8. Does everybody understand this? Why I said 16 pi by 8? Because it has to be less than 2 pi. Theta has to be less than 2 pi. And if 8 is the denominator, the top has to be 16 pi. Okay, so as soon as I see something just less than 16 pi, I need to stop. Okay, k equals to 0. When k equals to 0, this term is gone. So theta equals to 3 pi by 8. And when k equals to 0, this pi is gone. This term is gone. K equals to 0. In anything term 0, this term is gone. So I have got 2 solutions. Okay, but I need to keep going. It has to be less than 16 pi. Not yet there. Not yet there. K equals to 1. Theta equals to, k equals to 1, 8 times 1 is 8, 8 plus 3 is 11, so 11 pi by 8. Okay, so this is where I'm substituting. Let me highlight where I'm substituting for k, this equation, for me to calculate for theta. So I'm substituting for k. I did k equals to 0, now I have to do k equals to 1. So when k equals to 1, 8 times 1 is, 8 times 1 is 8, 8 plus 3 is 11, 8 times 1 is 8, 8 times 7 is 15k. 15 pi, what am I saying? Sorry, this becomes 8 pi plus 7 pi is 15 pi. And I think this is a good place for me to stop, because I know if I go any higher, it is going to be greater than 16 pi. So now I have 4 solutions. Okay, so we will stop now, and the next video will solve the next 2 problems. And please watch that.